For group 2, we had probability of compound events, independent and dependent, by Cassandra Vizcaino,
Ruby Pina,
and Brianna Casares.
Standards and grade levels. The grade level that this is usually taught in is 7th and 8th grade. It's a little viewed in high school, but it's mostly taught in middle school, which is 7th and 8th grade. Some standards is find probabilities of compound events using organized lists, tables, tree diagrams, and simulations. Understand that just as with simple events, the probability of a compound event is the fraction of outcomes in the sample space for which the compound event occurs. Represent sample spaces for compound events using methods such as organized lists, tables, and tree diagrams. For an event described in everyday language, identify the outcomes in the sample spaces, which compose the event. Design and use a simulation to generate frequencies for compound events. Day 1, introduction for independent events. For day 1, we'll be introducing independent events. How it would be taught would be showing 4 problems from Khan Academy and working with them all together as a group and going step by step. A problem that I chose would be if you flip a coin and roll a 6 die, what is the probability that you will flip a heads and roll a number less than 6? So we know a quarter has 2 sides, a heads and a tails. And we know a dice roll has 6 sides. We are looking for the probability of receiving heads and a number less than 6. So here I drew a tree diagram which has 2 branches, heads and tails. We know the probability of receiving heads is 1/2. And the probability, here we have a dice roll, which we also use a tree diagram. We have 6 branches for this one. In pink, I highlighted the numbers that are less than 6, which is 5/6. So the probability of receiving a number less than 6 is 5/6. So now we're going to use our independent events equation, which is the probability of A multiplying it by B. So how we represent that would be 1/2 times 5/6. So we would multiply 1 times 5, which is 5, and 2 times 6, which is 12. So our probability of receiving heads and a number less than 6 is 5/12.
So for day 2, it was the introduction for dependent event. For day 2, we would still be on Khan Academy. There's also a lot of problems on there for any type of topic that you can think of, but we would be introducing dependent events instead of the independent ones. We would work on these problems to make sure they understand the importance of dependent events and how to identify dependent event word problems. So we would put 4 questions up and work together as a group, or they can work on them by themselves. And we would also answer any questions if the students had any. So for solving a problem, I chose this question, which is in a class of 7, there are 4 students who play soccer. If the teacher chooses 3 students, what is the probability that none of the 3 of them play soccer? So there's actually 3 events happening in this situation, and the probability of the teacher choosing someone that doesn't play soccer is 3 out of 7. With that being said, there are only 6 students left. So we would take the dependent event equation and put 3 out of 7 multiplied by 2 out of 6 multiplied by 1 out of 5, which comes out to 6 out of 210, which equals to 1 out of 35, I'm sorry.
Day 3, reviewing and problem solving. For day 3, we would be reviewing compound events. We'd start off by going over what independent and dependent events are. So we would ask students to explain to us the difference between the two. We would review the definitions of those two. So an independent event is the outcome of one of the individual events that does not affect the outcome of another. And a dependent event is the outcome of one of the individual event that does affect the outcome of another. We would also include the equations for both independent events and dependent events so that the students would remember which each one looks like. We then go on to explain the diagrams that are used for compound events, which is a table and a tree diagram. And we would end off the day by solving problems. So for practice, we would have students go up on the whiteboard to solve the problems or in groups. So for this problem, it's a table and it has 100 people who were surveyed for their favorite fast food restaurant. So for the first question, it's asking what is the probability that a person likes Sonic? So students would have to find the section that says Sonic and calculate how many people in total like Sonic. So that would be 35 because there's 10 male and 25 female that like Sonic. So it would be 35 out of 100 since there were 100 people surveyed. And to simplify 35 over 100, it would equal 7 over 20. So that would be the probability of a person liking Sonic. For the second question, it is what is the probability that a person is male who likes Burger King? So you would have to go to the column where it says male and go to Burger King, and there's 15 people who enjoy Burger King. So it would be 15 over 100, and students would have to simplify it down to 3 over 20. For the last question on this problem, it's asking what is the probability that a person likes McDonald's or Burger King? So the students would have to look both at the McDonald's and Burger King section and calculate them all together. So they would be adding 20 plus 20 plus 15 plus 10, giving them 65. And they would put that over 100. And they could leave the answer like that or simplify it down to 13 over 20. Another practice problem would be using the tree diagram just so that the students can get a hang of using both diagrams. So for this problem, it's asking if we had a bag with 2 blue marbles and 1 green marble, what is the probability of getting the first marble green and a blue marble? So as you can see in the first draw, there are 2 outcomes. You can either get a blue or a green marble, but the blue marbles would be a fraction of 2/3 because there's 2 blue out of the total of 3 marbles. So you would use the tree diagram to see the probability outcomes, and the outcomes can be seen in the outcome section. So it's asking for 2 blue marbles and a green one. So the probability of getting a green on the first draw and a blue on the second draw would be 2 over 9. Mathematical practices. So some mathematical practices that we used was the fourth one, which is model with mathematics. In this lesson, we are using models to visualize the possible outcomes for each scenario. So we use both tables and tree diagrams.
Another mathematical practice that we use would be number 5 is use appropriate tools and strategies. For day 1 and 2, we use the probability equations such as the independent event equations to solve our problems.
We also used number 6, which is attend to precision. For day 2, we used equations when solving the problem to figure out the answer to the dependent probability problem that I had up from Khan Academy.
Growth mindset ideas. So teachers want to help students adapt a growth mindset. It will help the students view challenges as progress towards their desired outcomes. A way we would help create a growth mindset in our students is by teaching the values of challenges. Without challenges, students don't get the opportunities to take risks, learn to fail, and figure out how to pick themselves up again. We as teachers would also teach students to focus on learning rather than getting the right grade or the good grades. If students only think about getting good grades, they will develop a fixed mindset and learning may not result. When students focus their attention on learning while putting in the effort, grades will be a natural result of this effective learning progress. We'd also encourage students not to give up and to try new strategies. It's easy for students to give up when something doesn't work out on their first try, and it's important to encourage students to try out new strategies and learn from their mistakes. We also want students to reflect and learn from their mistakes. So, as teachers, we should be providing constructive criticism when mistakes are made while still praising their efforts. And for students, they need to acknowledge their error and see their mistakes as an opportunity to learn from them.
Misconceptions. The first misconception that we thought of are that students tend to make decisions about the outcome based on beliefs that are not completely in their control. Some examples would be God, wishes, luck, or wind. This is common in between students because when talking about probability, when talking about the probability of something happening, it seems like you're guessing or assuming an outcome when that isn't the case. For the second misconception, students tend to get the definition of independent and dependent events confused. It's a common misconception because they are similar to each other, and it's important to remember for dependent events, the outcome of one of the individual events does affect the outcome of another, and the outcome of one individual event does not affect the outcome of another, and that's for independent events.